This is topic 2.1, average and instantaneous rate of change. And we're going to recall what a rate of change is. And it's simply a slope. So our slope is, and let's start with 2 points. Maybe point number 1 has x and y coordinates, and point number 2 has x and y coordinates. And so the slope would be y2 minus y1 over x2 minus x1. And that is the change in y over the change in x. Now this delta, which looks like this, that means change in. Okay, so that's what we have. The slope is the change in the y coordinates of these points divided by the change in the x coordinates. Now, you might have the average change of a function, f of x, on this interval, AB. So that's really important, is to see that this is on this interval, AB. And that is represented by, and we'll go ahead and write average rate of change let's put that up here. And that's going to be f of b minus f of a over b minus a. So the y value at b minus the y value at a divided by the difference of their x values. So let's give one a try. Find the average rate of change from a function. You could say of a function. And so let's go ahead and highlight our function and our interval. So now, and I like to write these out, f of x is equal to the natural log of 3x. And we're on the interval from 1 to 4. So to find the average rate of change, we're going to have f of 4 minus f of 1 over 4 minus 1. So you might say, well, f of 4, you'll let x be 4, so it's the natural log of 12, or you could say the natural log of 3 times 4 minus the natural log of 3 times 1 all over 3. And you could do that and you could round and you would get a number. But what I would like to do is I would like for us to use our calculator. So I would like us, I can change pen colors here and put a little star here. I would like us to use this expression and put this in our calculator. So we will define f of x under the y equal button, okay? And then we will use y1 of 4 and y1 of 1 to compute. And this maintains the decimals, and we don't have to worry about rounding errors. So let's go ahead and do that. Let's get our calculator, and we need to go to the y equal button, and we're going to put this function right here. So that's the natural log of 3x. And this is an easy function, but should you have a very complicated one, you'll be happy you did this. Then second mode or second quit. And now we want y1 of 4, which would be this, minus y1 of 1. Remember, the function is called y1 in your calculator. So to get to that, you want to use the variables button, which is under this arrow. So variables, arrow over to y variables. It's a function. And we have our definition under y1. If you had put it under y4, you could choose y4. And then use your parentheses and put a 4. So there's our f of 4. Let's do the same thing for f of 1. Bars, y bars, function y1 of 1. Now, instead of using a whole bunch of parentheses, I like to put this numerator in my calculator and press enter, and then divide by that denominator, 4 minus 1, which is 3. So I hope that this helps with your computations, and now you can just put our solution, which is 0.462 rounded. Let's try the average rate of change from a table. So we don't have the function definition, but it's the same thing, the average rate of change, and we are on this interval, 2 to 30. So what's really important now, and you may like this, I'll go ahead and get a thicker one, is we're on 2 to 30. So highlight those somehow so that you remember that we're just using those. So that's f of 30 minus f of 2 over 30 minus 2. Now f of 30 is this y value associated with 30, which is 7, minus f of 2, which is a negative 2, all over 28. And we have 9 over 28. Okay, we're going to introduce two different expressions to represent the average rate of change and then the instantaneous. And you'll notice a big difference here because the instantaneous has limits. So let's go through all of those. So the instantaneous rate of change, you will be noticing that it's instantaneous because they have limits. Put that up there a little bit better. Okay. So let's take a look at these. F of b minus f of a over b minus a. Well, just here, we let b equal a plus h. Shouldn't look any different. Here, we let b equal x. F of b minus f of a over b minus a. So we can highlight those changes. There's our b, there's our b in this expression. They're two different expressions. Let me make sure you note this. These are two different expressions for average rate of change. Okay? So this first expression, just what you did, this is the slope of the secant line. Okay? Just what we had before, the average rate of change between two numbers, between 2 points. You might even look, here's a function, and maybe you have this between, I don't know, this point and this point, and so that's the average rate of change, this slope. So m is the average rate of change. Okay? Now let's look at instantaneous. We have limits, and these look just like these, except we have a limit in front of these. Let me show you something. Up here, do you see this is a plus h minus a? If you would cancel those a's, you'd have an h remaining. Do you see that down here? So that is something else to note. So you just take your time and work your way through these definitions. Again, these are two different, again, two different limits for the same thing, for the instantaneous rate of change. I'll put 4. Two different limits for the instantaneous rate of change. I like to call that instantaneous rate of change, and this is the average rate of change. Let me get this R up a little bit. Okay, so what do we notice? This denominator, H, note, I'll put a little note here. Let me change colors. Little star here and a little star here. The other denominator was A plus H all minus A, which is A plus H minus A. And then when you cancel those A's out, you have H. So it's really good to note that our denominator is the same here as here. Okay? So I guess I didn't do a very good job here of making that star. Let's see if I can get a different color. Star with the little black pen over it. There we go. So hopefully you can see that. Okay? So these are limits. So as H gets close to 0, this limit will give us the instantaneous rate of change. As X approaches A, do you see? If X gets close to A and the distance between X and A is H, if H is getting close to 0. So as X approaches A, H approaches 0. So our denominators represent the same thing with these limits. H approaches 0, there's H, this denominator is approaching 0. If X gets close to A, this X minus A gets smaller and smaller, so it's approaching 0. The difference between these is H is the distance between X coordinates. Okay, so A plus H and A are H units apart. So let's see how we can use these. In this first problem, we have they would like us to find the instantaneous rate of change of this function. So we need to make sure that we have this function noted, and also X is equal to -1. So here we want to make sure when they give us that value, A is really equal to -1. That is at our value. So A is what it's at. A is the value that it's at. Okay? So let's go ahead and try to find this first limit. The limit as H approaches 0. And we need f of A plus H, but A is -1. So this would be f of -1 plus H minus f of -1 all over H. Now, we have to find f of -1 plus h, so we're going to be putting -1 plus h in everywhere we see an x. So, keep writing this limit. So f of -1 plus h is -1 plus h, that's our x, minus -1 plus h all squared, that's our x squared. Now, let's subtract f of -1. So f of -1, if we would put -1 in here, it would be a -1 minus a +1, a -1 squared. So that would be a -2. So minus a -2 all over h. Let's simplify. We have -1 plus h minus, now let's FOIL this. -1 plus h squared is equal to +1 minus 2h plus h squared. So let's put a negative in front of all of that. So -1 plus 2h minus h squared plus 2. All over h. Now what do you notice? A +2 and -2. They're gone. So what we can do at this point is we can remove an h, divide every term. Do not do all this crossing out and writing on your work. You can now take an h out of every term remaining. So h over h is 1, plus 2 over h, so it'd be a plus 2, minus h squared over h, which is h. Now let h approach 0, plug it in, and our limit is 3. Okay, these are the same expressions for the instantaneous rate of change. This is the instantaneous rate of change. There are two different expressions. Let's see how this one works. We have the limit as x approaches -1, and we need f of x. F of x is just x minus x squared. It didn't give us anything to put in the function, minus f of a, which is a -2, all over x minus a, which is a -1. Let's take a moment to simplify, and we have x minus x squared plus 2 all over x plus 1. Let's see what we have here. Right there, we have a negative we could factor out, and let's rearrange. So this right there is the opposite of x squared minus x minus 2. Negative x squared plus x plus 2. So that will help us on this next line of work. And we can put the opposite of x squared minus x minus 2 all over x plus 1. Let's factor that numerator. And that's the opposite of x plus 1 multiplied by x minus 2 all over x plus 1. And now that we remove this denominator, which is where the problem was, and we plug -1 in, we get a negative, the opposite of -2, and that's a positive 3. Now, the most important part is that you know where all of these values came from. Now let's see if we can work backwards. The most important thing here now is to notice which definition are we using, x approaching a or h approaching 0. Let's start with the h approaching 0 definition. When we have h approaches 0, and we can write that down here, we have the limit, the limit as h approaches 0 of 5, as h approaches 0 of f of x plus h minus f of a plus h minus f of a all over h. So remember, our a, that's that right there, our a is our x value. And you can see a plus h, there's that 4 plus h. So our x value is 4, and the function is 5 times the natural log of 2 over x. And you can check this, 5 natural log of 2 over 4 is 1/2. Let's try one more here. This definition is x approaches a, so our x value is pi over 2. And this is f of x minus f of a all over x minus a. And what do you notice? Our function is right there in front of us. Here's f of x, here's f of x. So this is the sine of x. So that concludes this topic video.